This is day 11 of Advent of Cyber 2025, and this challenge is called XXX, Merry XSSMas. After last year's automation and tech modernization, Santa's workshop got a new makeover. McSkitty has a secure message portal where you can contact her directly with any questions or concerns. However, lately, the logs have been lighting up with unusual activity, ranging from odd messages to suspicious search terms. Even Santa's letters appear to be scripts or random code. Your mission, should you choose to accept it, dig through the logs, uncover the mischief, and figure out who's trying to mess with McSkitty. Learning objectives for this challenge are to understand how XSS works, and learn to prevent XSS attacks. So for this challenge, we need to turn on both the virtual machine and the attack box. XSS is a web application vulnerability that lets attackers, or even bunnies, inject malicious code, usually JavaScript, into input fields that reflect content viewed by other users, e.g., a form or a comment in a blog. When an application doesn't properly validate or escape user input, that input can be interpreted as code rather than harmless text. This results in malicious code that can steal credentials, deface pages, or impersonate users. Depending on the result, there are various types of XSS. In today's task, we focus on reflected XSS and stored XSS. So with reflected XSS, you see reflected variants when the injection is immediately projected in response. Imagine a toy search function in an online store. Search via URL, then search, and there's a parameter term equals GIF. Imagine you send this to your friend who's looking for a GIF for this nephew, and instead of a search term, include JavaScript, HTML tags, and JavaScript within it. Your friend clicks on the link and the code executes. The impact could be you could act, view, or modify information that your friend or any user could do, view, or access. It's usually exploited via phishing to trick users into clicking a link with malicious code injected. Stored XSS attack occurs when malicious script is saved on the server and then loaded for every user who views the affected page. Unlike reflected XSS, which targets individual victims, stored XSS becomes a set and forget attack. Anyone who loads a page runs the attack script. To understand how this works, let's use the example of a simple blog where users can submit comments that get displayed below each post. So this is a post request for a comment where the content is normal. But then with this one, comment includes JavaScript tags and JavaScript which would execute when the comment is displayed on the page. Because the comment is saved in the database, every user who opens the blog page will automatically trigger the script. This lets the attacker run code as if they were the victim in order to perform malicious actions such as steal session cookies, trigger fake login pop-ups, deface the website. To protect against XSS, each service is different and requires a well thought out, secure design and implementation plan. Our key practices you can implement are disable dangerous rendering paths. Instead of using the inner HTML property, which lets you inject any content directly into HTML, use the text content property instead. It treats input as text and passes it for HTML. Make cookies inaccessible to JS. Set session cookies with the HTTP only, secure, and same site attributes to reduce the impact of XSS attacks. Sanitize input, output, and encode. In some situations, applications may need to accept limited HTML input. For example, to allow users to include safe links or basic formatting. However, it's critical to sanitize and encode all user supply data to prevent security vulnerabilities. Sanitizing and encoding removes or escapes any elements that could be interpreted as executable code, such as script, event handlers, or JavaScript URLs, while preserving safe formatting. To exploit XSS vulnerabilities, we need some type of input field to inject code. There is a search section, let's start there. So to exploit reflected XSS, you can use test payloads to check if the app runs the code injected. If you want to test more advanced payloads, there are cheat sheets online that you can use to craft them. Now we'll pick up the following payload. It's just this. Okay, I think we need to actually go back to the top and get the website set up. So in our attack box, we'll bring up Firefox. We'll then go to the URL of the virtual machine. So for mine is http://10.49.169.11 should be the IP address that appears here. And now we've got the website that's running on the virtual machine. So back down to here, we copy this script, add it to our clipboard, and then paste it inside of here as a search term. When we click search messages, this will be added to the query of the URL. And then it should also appear the alert pop-up for reflected meow meow. When we run that, we can see reflected meow meow. And after doing that, we've now got our first flag, which let's copy it from the clipboard here, copy, and paste that to there. And we may as well do the first one, which is which type of XSS attack requires payloads to be persisted to the backend. That is stored. Okay, so now for the next one, for the stored XSS, let's copy this script, which is stored meow meow. And when we go down to here, we will paste that into here, and this will be saving it to the back end. So anyone who goes to this page now would see the alert stored meow meow. So let's send that, and as we can see, there's stored meow meow, and we can see here we've now got the flag for the stored XSS tab. Clipboard, paste that down here, and that is day 11 of Advent of Cyber 2025 completed. Like this video, make sure to like and subscribe.